Quantum mechanics is a fundamental theory in physics that describes the behavior of matter and energy at the smallest scales, such as atoms and subatomic particles. It provides a mathematical framework for understanding the wave-particle duality of particles, the probabilistic nature of quantum phenomena, and the uncertainty inherent in measuring certain properties of particles. The double-slit experiment is a classic experiment in quantum mechanics that demonstrates the wave-particle duality of particles. It involves shining a beam of particles, such as electrons or photons, through two closely spaced slits and observing the resulting pattern on a screen behind the slits. Surprisingly, even when the particles are sent through the slits one at a time, an interference pattern emerges on the screen, similar to the pattern created by waves. This indicates that particles can exhibit wave-like properties and interfere with themselves, suggesting that they possess both particle and wave characteristics. Planck's constant, denoted by the symbol h, is a fundamental constant in quantum mechanics. It is named after the German physicist Max Planck, who introduced it in 1900. Planck's constant relates the energy of a quantum, or packet, of electromagnetic radiation to its frequency. It defines the scale at which quantum effects become significant. The value of Planck's constant is approximately 6.62607015 times 10 to the minus 34 joule-seconds. Planck's constant also plays a crucial role in the wave-particle duality of matter. In quantum mechanics, particles such as electrons are described by wave functions, which are mathematical functions that represent the probability distribution of finding the particle in different states. The wavelength of a particle is inversely proportional to its momentum, and Planck's constant appears in the relationship between the wavelength and the momentum of particles. This connection between energy, frequency, and wavelength is encapsulated in the famous equation E equals hf, where E represents energy, F represents frequency, and h is Planck's constant. Overall, quantum mechanics, as demonstrated by phenomena like the double-slit experiment, challenges our classical intuition and provides a framework for understanding the behavior of particles at the microscopic level. Planck's constant is a fundamental constant in quantum mechanics that relates energy and frequency and is central to our understanding of the wave-particle duality of matter and the quantization of energy.